Hey everyone, welcome to physics. We are going to use Coulomb's law to solve for distance. Before we get started, let's take a look at this equation just to remind ourselves what each of the variables stand for. So again, F stands for force. The K is that constant K value that you're always going to be given. You're never going to have to memorize it. It's right there over to the right. Q1 represents the first charge. Q2 represents the second charge. And the denominator is distance. Be reminded that distance is squared, and again, squaring something is not the same as multiplying it by 2. So let's read our question here. It says, the force between two charges is 1,000 newtons. One has a charge of 2 times 10 to the negative 5th coulombs, and the other has a charge of 5 times 10 to the negative 6th coulombs. What is the distance between them? So since they're asking us to solve for distance, I'm going to put a question mark here. And then I'm going to fill in my variables for everything else. So they told us that the force is 1,000 newtons. So I'm going to write that on the line. The K value is given to me up there at the top, 9 times 10 to the 9th newtons times meters squared over coulombs squared. The first charge they told me about was 2 times 10 to the negative 5th coulombs. And the second charge they told me about is 5 times 10 to the negative 6th coulombs. Okay, so I'm going to plug all of these into my formula over here on the right. So the force is 1,000 newtons equals my K value, 9 times 10 to the 9th. My first charge, the Q1, which is 2 times 10 to the negative 5th. And then my second charge, which is 5 times 10 to the negative 6th. All over distance squared. You might be thinking to yourself, oh man, this is a hot mess. My variable that I'm looking for is in the denominator. This is bad. It's not bad. The easiest way to pull that denominator out is to just cross multiply. And remember, underneath any whole number is an invisible number 1. So all you have to do is cross multiply. And this is kind of the easiest way to get that out of there. Like so. So when you multiply the yellow numbers together on the left-hand side there, you're going to have 1,000 newtons times d squared equals, and then just rewrite out everything. Don't worry about plugging in your calculator just yet. So 9 times 10 to the 9th. 2 times 10 to the negative 5th. And then 5 times 10 to the negative 6th. Okay. Don't forget, use parentheses, keep yourselves organized. Use that exponent function inside your calculator. It'll just make your life a lot easier when you're trying to multiply all of these numbers that are in scientific notation. Okay, so now's where we want to start cleaning things up. Please don't try to plug everything into your calculator, multiplication and division. It's easier to just take it step by step. Okay, so I'm going to highlight this distance squared just so that I don't lose it and I know what I'm looking for. So I'm going to copy 1,000 newtons times distance squared one more time. And before I copy down everything on the right, I'm going to multiply those numbers in my calculator. So 9 times 10 to the 9th, multiplied by 2 times 10 to the negative 5th, multiplied again by 5 times 10 to the negative 6th. And if you're keeping track of your variables here, you're going to see that these coulombs are going to cancel. And when you multiply all of those numbers inside your calculator, you are going to get 0.9. So 0.9, and the only units you were left with were newtons and meters squared. That's going to be a lot easier to plug into your calculator. So what you want to do is isolate that variable on the left, and the way to do that is to divide each side by 1,000 newtons. And that number is going to, and unit is going to cancel on the left, and these units are going to cancel on the right. And when you divide those numbers in your calculator, you're going to get 9 times 10 to the negative fourth. So let's copy down our distance squared here. 9 times 10 to the negative fourth. And then you'll notice the only unit you have left there is meters squared. Well, I don't want distance squared. They're asking me what's the distance between them. And the way to get rid of a square is to square root it. So when you square root that number inside your calculator, you're going to get that distance equals 0.03 meters. And that should make sense because if you're keeping track of your variables going through this entire problem, basically you're whittling down to the last variable, and that's an easy way to make sure that you're on the right track because you ended up with meters squared here and meters squared here and meters right here, which is the appropriate unit for distance.